This is the first mini-lecture for section 6.2 of the textbook. In this section we're going to talk about addition and subtraction of fractions. So let's suppose we want to add 1/2 and 1/3. So what would be wrong with the following? You see this often among middle school students, high school students, college students, where in the attempt to add two fractions, the student will just add the numerators and then add the denominators, and then get this answer 2/5. Okay, so let's think about what's wrong with that. Well, it makes no sense. For one thing, 2/5 is already less than 1/2. How could you add something to 1/2 and get something that's smaller than 1/2? So just on those grounds, it doesn't make any sense. But when we do something like this, we're ignoring what the fractions are supposed to represent. Go back to how we originally described fractions as actions. 1/2 means you take the unit, the loaf of bread, whatever it is, you cut it into two equal parts and you take one of those parts. 1/3 means you take the loaf of bread, cut it into three equal parts, and you take one of those parts. So the idea is we're trying to put those two parts together. Well, that's not going to be 2/5. No one is dividing the loaf of bread into 5 equal parts here. Okay, so in order to add a pair of fractions like that, the first thing we need to do is make them kind of speak the same language. And we do that by finding common denominators. We can use the fundamental law of fractions to do that. So, for example, 1/2 is 3/6, 1/3 is 2/6. So 3/6 is 3 parts out of 6. 2/6 is 2 parts out of 6. So if I put those together, I end up with 5 parts out of 6. Okay, so let's draw a picture of this. But I'm going to use hexagons, just because we know that 6 is going to be involved. Okay, so this is supposed to be 1/2. And let's divide that into 2 equal parts, which aid in one of those. Okay, now to that I'm adding 1/3. So I'll draw a picture of 1/3 using the same unit. It's important that the size and shape be the same. Okay, so I'm going to draw the 1/3 so that it's pretty clear how it's going to fit in with the 1/2. Okay, so there's the 1/3. So I put these together, and the idea is I'm just going to combine those two shaded regions. But I can see precisely what I'm going to wind up with if I find a common denominator graphically. So I know that the common denominator is going to be 6. That means that each of the halves need to be divided up into 3 equal parts. Like this. And each of the thirds need to be divided up into 2 equal parts. Like that. And now I see I've got 3 parts plus 2 parts. When I put them together, I'm going to get 5 parts. So let me draw that separately. And, I'm winding up with 5 parts out of 6, so that's the answer, 5/6. I'll shade these darker to kind of distinguish them. Okay, so, hopefully this makes it clear why 2/5 just doesn't make sense as an answer. And, I could have actually done this. I could have worked through the whole thing without knowing the answer ahead of time. I could have used the picture to figure out the answer. And that's something you could do if you use manipulatives like fraction circles. Okay, in general, we add in subtraction by finding common denominators. It's usually easiest to use the least common denominator because it just keeps the numbers smaller. Okay, but that doesn't really come up in these examples. Okay, so let's try to use fraction strips to illustrate the sum 1/4 plus 2/3. Okay, so remember when you use fraction strips, the idea is to use a long rectangular strip, or rather a set of long rectangular strips that all have the same length. Okay, so this is supposed to be 1/4. Cut it in half and then cut the halves in half. Okay, and then you take a second strip, and I'm going to line it up like the book does. I want it to be this exact same length as the strip before, but I'm going to place it so that it starts where the shaded part of the other one ends. Okay, and I need to divide this into 3 equal parts. Yeah, just trying to be as careful as I can in doing that. Try to make it as exact as I possibly can. Okay, so I add those together. And see, at this point, if I'm really careful, I could actually draw the answer. I'm going to line it up with the original strip. I'm not going to try to shade it in yet, but I could. Just pointing that out, that like graphically we already have the answer. It's just a matter of putting those two shaded parts together on one strip. But I want to be exact about it, and I want to see how to write the answer. So what I need to do is find a common denominator. See, 1/4 is 3/12, and 2/3 is 8/12. So I'm going to take this 1/4 and also draw it as 3/12 by using dashed lines to divide each of the parts into 3 smaller parts. And similarly, I'm going to take my 2/3 and divide each of the quarters into divide each of the thirds into 4 smaller parts. Okay, then now the answer. I'm going to take this strip and divide it to twelfths. So I'll start by dividing it to quarters. Divide the quarters into thirds. And now let's shade in, well, it's going to be 3 plus 8 or 11 twelfths. Added some little lines here to show you how it's supposed to line up. It's not perfect, but when you draw this, try to get it as close as you can.